All right, guys, there's a section B because there's something called compound units, and compound units utilize those units we've covered already, like length, time, amount, all that stuff. And there's a ton of compound units out there. We're going to go over these three. Now, temperature is slightly different. We're going to talk about that for a moment, but volume. So volume is 3D space. It's the three-dimensional space that stuff takes up. All right. Now, one of the things about this unit is, first of all, volume's capital V. All right. We measure this in liters usually, but we can measure it slightly differently. Okay. So we're going to have to you're going to have to follow me here for a minute. All right. Because we just did those prefixes. And so I think you can do this. All right. So 1 liter equals 1 decimeter cubed. Okay. What that means is 1 liter equals 1 decimeter times 1 decimeter times 1 decimeter. Okay. We can keep going and we get 1 liter equals 0.1 meters times 0.1 meters times 0.1 meters. So we get that because a decimeter is 1/10 of a meter. So no big deal, right? Well, we're going to change it. 1 liter equals 100 centimeters times 100 centimeters times 100 centimeters. All right. Now, I think you can, nope, that actually equals 10 centimeters. 10 centimeters, 10 centimeters, because it's 0.1 meters. So you see my mistake there. Glad I caught myself, or else this would have been a disaster. So 1 liter equals 10 times 10 times 10. So that is 1,000. A centimeter times a centimeter times a centimeter is centimeter cubed. So 1 liter equals 1,000 centimeters cubed. Well, 1 liter also equals 1,000 milliliters, right? So we can see 1,000 milliliters equals 1,000 centimeters cubed, which means 1 milliliter equals 1 centimeter cubed. This is something you should remember. So that's not too bad. So volume. All right, we're going to use liters to talk about volume. You can apply all those prefixes that we talked about to this. All right, but volume's 3 lengths multiply. So then we have the almighty density. You are my density. That's a line from Back to the Future. If you haven't seen that movie, shame on you. Density is lowercase d. Now, density describes the amount of mass per volume. Okay, so whenever you say per, that means 1. So miles per gallon is how many miles you get from 1 gallon of gas. All right, now density. Now this equation is D equals M over V. Density equals mass divided by volume. All right. There's a trick to this. It's called the density triangle. Now, this is one of those algebra situations, right? You could solve for density, you could solve for mass, or you could solve for volume. You're going to have to solve for this denominator. So you're going to have to understand algebra. There's a bit of a trick, though. I'm always a little apprehensive showing people this. This is the density triangle. Here we go, density. So you have D, M, and V. All right, so what you can do here is the thing that you're trying to find, you can cover up, and it shows you what to do. So if we want density, it's mass over volume. Look at that, mass over volume. If you want mass, then it's density times volume. And if you want volume, then it becomes mass divided by density. So that's our little trick for density. Finally, and we're going to do a ton of problems on this. This is going to be in the practice segment. Temperature. which is capital T. All right, now there's two different modes of temperature we can use. Celsius, which is degrees C. All right, now Anders Celsius developed this temperature scale, and the reason that he did it was when you look at the Fahrenheit scale, nobody really knows what it's based on. But Celsius was like, let's base it on water. And so he said, water boils. I think I can use H2O. We know that that's water. Boils at 100 degrees Celsius. And it freezes at 0 degrees Celsius. This is why Celsius sometimes is referred to as centigrade scale. Centa, 100th, just like what we did with those prefixes. Every degree Celsius is 100th of the boiling point of water. That's why it's centigrade. If we come over here, use this here. We're doing Kelvin. And this was developed by William Thomson. William Thomson did a lot of work in thermodynamics. He figured out what absolute zero is, which is the coldest possible temperature, which is 0 Kelvin. He's made Lord of the Kelvin River Valley, hence Kelvin is named after him. Anyways, this is an absolute temperature scale, which means there's no negatives. Because there's no negatives, we don't have to worry about negative in math, which is really good. And so we need a conversion between Celsius and Kelvin. Okay? And that conversion is pretty easy. Kelvin equals Celsius plus 273. And that's it. All right? Because on a practical level, we usually measure the temperature in Celsius. But when we start talking about different scientific principles, usually it's measured in Kelvin. All right? And the reason that we measure in Kelvin is because we can never have negative values. Can you have negative 5 degrees Celsius? Oh, yeah. It can be negative 5 outside in Celsius. That is absolutely possible. Can you have negative 5 Kelvin? No, it cannot go below 0. And frankly, we've never gotten to absolute 0 yet. So anyways, these are two scales. We're going to go through and do some practice problems. So look for Unit 1, Section 2B practice problem.